Okay, everyone, we will discuss the next lab that you'll be doing, which is an experiment on acid bases and pH. This is a pretty straightforward experiment where you're going to create a acid-base indicator using red cabbage, and then afterwards you're going to use that indicator solution to determine the pH of household solutions, and then determining whether these household solutions are acidic, basic, or neutral. So we're going to start by talking about what pH is. It's just a number that typically goes between 0 to 14, although it could go lower than 0 or higher than 14. And it represents the acidity or basicity of a solution. So just how acidic or how basic that solution is. The pH is always written with a lowercase p and an uppercase h because the p stands for power. So it's like the mathematical exponent, and then h for hydrogen. So the hydrogen here is referring to the hydrogen ion, which is H+. And the way we calculate pH is by taking the negative log of the hydrogen ion concentration. So that's what's shown here mathematically. Now, because of the negative sign, there is an inverse relationship between the concentration of H+ and the value of pH. So if you have large value of H+, the value of pH will be smaller, whereas if you have a small value of H+, then the higher the pH is. And that gives us a way to designate whether a solution is acidic, basic, or neutral as indicated right here. A solution that has a pH of less than 7 is considered acidic, whereas if its pH is higher than 7, it's considered basic or alkaline. If the pH is exactly at 7, then it's considered neutral. Pure water would have a pH of 7. A pH indicator, which is the substance you'll be making using the red cabbage today, is a substance that when you add a small amount of a sample solution will change its color. You might have heard of the litmus paper or the litmus test, and that actually comes from an acid-base indicator that has two colors. It's red and blue. So red when it's acidic and blue when it's basic. So if you take a litmus paper and you dip it in a solution and its color changes from red to blue, then you know that solution is basic, and vice versa. In this lab, you're going to use a natural indicator, which is the red cabbage, and you'll see that when you do the experiment, the color of the solution from the red cabbage will change depending on the pH of the solution you're testing. Using that value of the red cabbage indicator solution, you're able later on to narrow down the pH of a given household solution. So you might wonder where you can use this. Well, one specific example where people use pH indicator is testing the water for a swimming pool, because we need to make sure that it's not too acidic or too basic for people to swim in it, because it would not be healthy for the skin. In addition to using pH indicators, you can also use something called a pH meter, which is shown right here. This would be a really simple one and portable that you can take everywhere. And all you will do is just take this and stick it into a solution, and it will read you a number, and that number would be your pH. Typically, we would do this for application in the environment. For example, for rainwater, we expect rain naturally to have a pH between 5 and 6. Slightly acidic, but nothing harmful. But if you live near areas where there are a lot of air pollution, which generates either nitrous or sulfur oxides type of gases, those gases can combine with water to form acids, either sulfuric acid or nitric acid, and that would result in a pH that's less than 5. So for example, if you look here in this pH scale, as we said earlier, a regular rain would be 5.6, but acid rain would be about 4.2 or 4.3. So it's pretty acidic compared to the clear rain. Now, the interesting thing is you might think that there's not a whole lot of difference between those two numbers because it's only about 1.2 or 1.3 difference. But recall that the pH scale is what we call a log scale, which means that a difference of 1 is equal to 10 times the hydrogen ion concentration. So when we say the acidic rain is 1.5 pH unit less than clear rain, we're really talking about a much larger number of hydrogen ion present in the acid rain compared to the clear rain. That's the reason why we can see that all the organisms that live in lakes and oceans and so on will die at that pH because they're used to living in an environment where the pH is much higher. Having too much base is also not good. So for example, if you have a leak of chemicals that contain a lot of base, that could also result in a change in pH where it goes up higher than 6, let's say. And many of the same organisms would not survive at a higher pH compared to what is normally present.